Welcome friends, in this one we're going to explore the concept of a degree of freedom, hopefully as gently as possible. Take a look at this situation. Here's an equation. It says x plus 4 is equal to 10. If you think about this equation, it's not like we can just choose the value of x to be anything that we want it to be, can we? Imagine somebody says, well, I can just choose x to be equal, for example, to 3. No, because 3 plus 4 is not equal to 10, right? So 3 plus 4 here is not equal to 10. So I cannot just choose x to be 3. I can solve the equation. I can find that following is true. X must be 6 because 6 plus 4 is equal to 10. In other words, I don't really have any freedom over the value of x. It just already is forced to be 6 because of the nature of the equation. So in this case, we would summarize this by saying the following for this example right here. This equation x plus 4 equals 10 has no degrees of freedom. Look at the next one. It's going to be a little bit different. Let's think about this. So imagine I gave you now x plus y is equal to 10. This is a little bit different. You see on the left side you have two variables, one is x and one is y. Now let's look at the next example. So x plus y is equal to 10. I just made that up, but look at the left hand side. There's x as a variable, there's y as a variable. What I can do that's different compared to the previous example is this. I can say that x or y, in other words, one of the values, I can choose its value. So I can say that y should be equal to, for example, 3. We can choose this value. In other words, it doesn't have to be y equals 3. I can equivalently say that y, for example, should be equal to 7 or y should be equal to 1.5. I am free to choose the value of y. In other words, what this is giving us as a result is we have 1 degree of freedom, not 2, for the following reason. Look carefully. Imagine that you do arbitrarily decide that y should be equal, for example, to 3. Then x must be 7. It cannot be any other value. I cannot determine its value arbitrarily. I can't say that when y is 3, for example, x is 25, because 25 plus 3 would not be equal to 10. That's what we mean. The overall conclusion for this example is the following, that we have 1 degree of freedom. Look at the next example. X plus y plus z is equal to 15. You really should pause the video and decide already how many degrees of freedom this equation has. But let's think about it. On the left side, I have 3 variables, x, y, and z. Of these 3, I can, for example, arbitrarily decide that x should be equal to 1 and y should be equal to 13. Why not? I can do that, no problem. Which means that z must be, it's not a choice that I have anymore. As long as I want to follow the equation and say that it must be equal to 15, then z must be, well, 13 and 1 is 14, so z must be 1. Because 1 plus 13 is 14, plus 1 more, the value of z is equal to 15. Let me do another one here, take a look. Imagine x has the value, for example, 3, and y has the value 10. So I'm choosing those two however I want pretty much, which then tells me the following, that z must be, well, 10 and 3 is 13, so z must be 2. I cannot choose the value of z as long as I want to follow this constraint that the sum of the 3 is equal to 15. Therefore, the overall summary on this example is the following. To summarize it, I would say this equation has 2 degrees of freedom. So in the context of equations, if you look at all of these examples, right, what do they all suggest? Degrees of freedom represent the number of pieces of information we are free to choose. Once you've exhausted your degrees of freedom, there might be one last piece of information that, for example, completes an equation that you're not allowed to choose. So in other words, if you look at these, right, this equation here has 1 variable, 0 degrees of freedom. This equation, x plus y equals 10, has 2 variables on the left side, 1 degree of freedom. This equation, x plus y plus z, has 3 variables on the left side, 2 degrees of freedom. So for an equation with n variables, we have n minus 1 degrees of freedom. This is the kind of concept that gets applied, for example, in statistics. But its origin is something relatively simple like this. So if this has been helpful, friends, please leave a like and subscribe. Thanks so much for watching. I'll see you in another video.